And it's doing so there, and it says I'm live. It says we're live. This is good. This is exciting. Now, here's the moment of truth where I wait for my screen to like refresh, and there it is. Hooray! Welcome. Can you hear me?
Well, me? Yeah, oh, yes. Yes, I can hear you. Yeah.
Hooray, that's exciting. We already have, well, I don't know, some number of people watching. It said 35, and then it said 23, and it's jumping all over. Now 29.
Well, I'm not starting before it's 50 at least.
50? It's 50 people. I could just make that up. You don't have the indication on your screen.
Good. Can you hear me well?
I hear you very well.
Okay, good.
Yep. Well, so, yeah. Well, we can wait a few minutes, but we do have a lot of we love our live audience, but they are vastly outnumbered by the people that watch later. So, you know, if they take too long to show up, we can start with that.
I have time. That's fine.
Okay. So, so you're Sebastien Ross. So we talked to you before a while ago, a very popular show. You talked to us about Orchard, I believe. And today you're here to talk to us about benchmarks and performance.
Nope.
Oh, no?
Yeah.
What are you talking about?
Yeah, benchmark and performance, yeah.
Okay.
Yeah, Damien usually talks a lot about it, but just the results. And I will show you everything but the results. How do we get the results?
Okay. You're going to be talking about the nitty-gritty, like how we actually bump up our performance and
how we measure what are the tools we have to measure, and then I assume we'll have time to show you some the results of an article I've been writing from feedback we've got on the issue tracker about how we can detect memory leaks and GC issues, and so I will show you some techniques and some actual results about how the GC works in ASP.NET Core.
Great.
Yeah.
Okay, so before we get to that, let's switch over and I'll show the community links. So I'm going to share my screen, and then you, I believe, have to hit some sort of button.
I'm done. It's beautiful.
Yeah? Okay. And then, of course, once I share my screen, my computer slows to a crawl, so I have no idea what's happening. Great. So you can see my screen now?
I can.
Great. Okay, so we showed this link off last time where we've got we did the announcement show for ASP.NET Core 2.2.0 Preview 1. And so this is the announcement post. This is kind of meta here. This is our video from last week's show here. But the thing I wanted to point out is that this bullet list of features is actually now blog posts. So you can go over and you can read blog posts that dig into these different features. So I'm not going to go into those now. I'm just pointing out that they're available. Dan went through and did feature overviews of all these, but you can go through, you can get code samples, you can dig into all this stuff about how to use them. So there's one on endpoint routing. There's the SignalR Java client. There is this one about open API analyzers and conventions. HTTP2 and Kestrel, and health checks. So there's a ton of stuff there. So that's pretty neat. And again, with all of these, there's code samples, there's all kinds of stuff to dig in and get a lot of in-depth information. This is kind of neat. This is Damien Bowden. He just shared this out on Twitter, and I thought this is pretty cool. This is a template that he's building out. This is ASP.NET Identity with Identity Server 4. And one of the interesting things he's been doing is he just called out for some contributions for localization. And so the community's been jumping in and adding in a bunch of localization for this as well. So this is, I love this identity or this template system, just .NET new -I, and you can install that using that template. So neat stuff. Okay, I got two links to feature. Maxime pointed these out to me. So one is there are some docs on using source code linked from a NuGet package. So there's tons of great NuGet packages you're going to want to use in your applications. If they're set up for source link, then like number one, you get this source code reference here that you can see. And so this talks about how you can go through and update your new spec in your project file to light that up. But secondly, this also integrates with SourceLink. And with SourceLink, then you can go through and you can actually, directly from a NuGet package, you can do things like debug into the source code. So here's another, this is cool. Maxime kind of called this out, and Carlos took up the challenge. And so he went through and did a walkthrough where he's going through and setting up SourceLink. So he shows, just a few minutes work really here to go through and set this up. And then how it's integrating in, and he's getting the SourceLink debugging experience. So this is just a call to action for people that are creating NuGet packages, that this is pretty easy to set up and something to take advantage of. All right, so Hisham dug into an interesting one here. This is localization for generics. So if you've got a generic class, it's not quite as simple as you might have thought, where you could just go through and create classes using this, application user of type t.fr.resix. Instead, he goes through and explains how you actually have to get the base name to use, and he shows an example here where he's going through and using that. So digging out and using that base name. Worthwhile to know about. Joe Audette explains you can get into this feature, and I've actually run into this where I'm doing a demo where I'll go and I'll show I've created a new project, and I'll accept, and then I'll think, okay, well, now I actually want to show what would have happened if I didn't click accept. How do you revoke that? How do you go and revoke that permission? So he goes through and shows how to show how you can go and revoke that permission. So it's that permission, there's the client-side cookie and synchronization to the back end. And so it goes through and explains how to do that. So that is cool. All right, just a few left here. This is interesting. Steve Smith talked about a cached repository in ASP.NET Core. So the repository pattern, there's people that get all up in arms about it. I personally feel like for some, a relatively small size project where things are scoped, it's worked well for me to use a repository. If you're using a repository, this is kind of a neat idea of layering a cache on top of that. So he explains, here's the very simple repository pattern, and then going through and adding caching on that as well, and so that you've got a cache, built on top of that. And because it's managed at that layer, you can do things like change around durations and that sort of thing.
So next step, we have to ask him to make it distributed invalidation of these things. Because if you have a distributed environment like cloud native, you want the item to be invalidated if one of the instances updates the repository entry. So I want next week to see the distributed invalidation.
All right, feature request, Steve. Yeah, that's a good point. Slightly related to what you just brought up there, Cosmos DB. Thomas blogged on this. So this is, I've seen this before where people use RethinkDB, and RethinkDB is a database that has this whole idea of, it can send you notifications, a change feed, basically. And so Tomas went through and set this up using Cosmos DB. So there's a change feed that he's set up and exposed, and then pulling that in from an ASP.NET application. So that's kind of a push base from your database to receive those changes. Pretty cool. All right, and my last one here, this is Peter Kellner, and he's got this overview, a nice in-depth article. I would call this a full article here. It goes into a lot of depth here, explaining, and with a video too, explaining the difference if you're used to partial views and haven't kind of made the jump over to view components or written a view component yet. He explains what they provide for you. So I've used Vue components in places in a website where I want to package and reuse something in multiple places in the site, and I don't want to modify all my controllers the way that I normally would have to with a partial. So he explains kind of the benefits of being able to package something as a Vue component, and then go through and set that up and take advantage of that. So very nice meaty post. And again, as I pointed out here, there's the video at the top as well. So excellent stuff. And now I almost stopped. I almost hung up on the call, which would have been bad. Instead, I will just stop sharing. And I'm done.
Thank you. Yeah. So my turn. So
it's your turn. And have you switched over the view back to including yourself as well?
I don't know what you can see, but yeah, everyone can see both of us, and yeah, that's
excellent.
So what I want to show you is how we do measure the things that we expose on the web for performance. So you might know already. I assume you know. I hope you know that there is a link, aka.ms/ASPNET/benchmarks, that goes to a dashboard of numbers, charts, KPIs, and everything that displays all the perf numbers that we collect over time, and we collect them many times per day to follow the evolution of that things. So these numbers are very interesting, but I've been working on actually measuring all these numbers, and the thing we've put in place to measure that is I think super useful to be able to benchmark any application. And I wanted to show you how you can reuse that because it's actually open source. A few of you have used that or tried to use it in some environments. I might mention you. And yeah, I just wanted to show you how you can reuse it because I think it's super useful if you want to benchmark your own applications. And also we use it internally in the ASPNET core team, but also the .NET core team is using it to measure some things or to help us investigate the different issues we find. And also externally, so people like Ben Adams have been using it without knowing because they just ask me, can you run this change and see the perf impact? And I'm just running it for them. And yeah, I will mention some examples with contributors who've used that maybe unknowingly, but that's super useful. So you see we kind of graphs here to measure specific scenarios like plain text, JSON, which are tech emperor scenarios. And we also have a page for KPIs, which will show us, might be not super big. Let me see if I can increase. Nope, doesn't work. So yeah, KPIs yeah, that works actually. To drive the, wow, it's lagging. Yeah, to tell us if we are good or not during the last 3 days or the last 10 days to detect regressions on Linux, Windows, cloud, physical. And then we also have some things like reliability testing. So we measure continuously some apps that run for days or for weeks. And we can track the memory usage, the CPU, and detect, for instance, memory leaks. Like, I think it was around February, we found a graph of memory which was going up during one day to like doubling the memory. And then we found a memory leak because of that. So it's very important to see how the apps react over time. So we have one chart where the application is restarted every day, and every day we take the new bits which are on the get, or on my get, sorry. And then we also have a chart that runs a system for a week. And you see here, we have a week of running with throughput and a week of running with CPU, memory, and latency. Okay. And sometimes there are issues in the either a request or the measurement, which actually adds the result in the same second that we get the result. That's a technical issue. And so that's super useful, and we can see on Linux and on Windows. We run these on Azure to be as close as possible as what our customers will use. We have a chart for SignalR, which is daily chart. We have the same thing for stress testing, long running. And we have a custom chart where you can compare all the scenarios that we are testing and check the different server for orchestral transport, cloud or physical, Linux or Windows, HTTP, HTTPS for some scenarios, and then it's like a self-served list of charts. So that's what we expose publicly. And that's what we use also internally to measure everything. But it's not just what we have internally. We also can run ad hoc tests for specific changes and specific scenarios, specific variables. I will show you how.
So I have a question for you. Hopefully I'm not interrupting too early here. These are visual. You can browse out to that and you can see these charts. Do you have anything that kind of like runs, like that notifies you if there's a regression or that kind of thing that's automatic?
Now we use the KPIs for that. We daily look at the KPIs to see if there is a regression because it's hard to detect those. Like they can be in like 2%, sometimes 2% can be expected, or it can just be noise of or the machine which is slower a day than the other. So that there's lots of variables. It's kind of hard to detect those changes. And if we see a 10% drop, because we look at it every day, we'll see it.
Okay.
What we could make better though is the coverage of what kind of scenarios we are testing. So we do test Kestrel as is with just rendering text. We do just test JSON. We test it in a web API. We test it in a middleware. We test entity framework on updates, on inserts, on reads. We test Razor, we test MEC, we test all the components individually and sometimes also together. Like we have an app that does MVC, Razor, EF, but what we might miss is actually some specific kinds of loads, like using specific type of objects or some things that customers might do and we are not looking at. So there are gaps in the stress testing. So that's why we still look at the issues that are filed online and try to investigate them when people file issues. And this is actually the second part of my demonstrations, how we reacted to one of the issues that was created on the GitHub repos and tried to investigate those reports to see if they were legitimate or false negatives. I think answer the question. But over time we'll add more types of tests to be able to detect things that we don't cover so far. In terms of performance, regression, and also in terms of reliability. Okay, there might be some weird objects in .NET that we are using that has a memory leak and we don't know it yet. And maybe a customer will find it live and we'll have to fix it, but it will be better for us to know about it before. So that's one of the goals that we have. But that's progress from last year that we had something like this, but now it's public and we can collect more data about more metrics. So that's already super useful for us.
Okay.
So let me show you how we do that. So we have a repo. Oh, let me switch back. Yeah, we have a repo on GitHub, ASPNET benchmarks, this one. So this repository contains everything to measure what we can see in these graphs and more. So I think this is useful to show you how it works because I will hope that you can run it, customers can run it in their own environment and be able to measure their apps and find perf issues and investigate these issues with this tooling. I know some of you have already tried. I know, for instance, Maher helped me to configure or I think we still have his PR, to configure it to run Windows because it's using Docker. So I know people are interested into running that. And so we try to document how to set it up, but still the documentation doesn't explain what it does. So I will show you how it works, and then maybe you will be interested into looking at how to install on your system. So the idea is that we run a service to start an application, any application you want. And this service will be on a dedicated machine, which we call the benchmark server. Okay? This is a web app done in ASP.NET Core that will take jobs to run an app. And we have another service called the benchmark client, which will send a load, an HTTP load, to the service that is running, to the application that the benchmark server has started. So two different web applications. And to measure performance correctly, we run them in different environments, different physical machines, okay? Totally independent machines. So the application is the only thing running on the benchmark server, and the load testing is the only thing running on the benchmark client. Okay? And these two services, benchmark server and benchmark client, take jobs. And they can queue the jobs. Queue the jobs to start applications and queue the jobs to start a load. And the load, by default, for us is using WRK, which is a Linux tool to send a set of HTTP requests with specific number of connections and threads. And then once it's running, the benchmark server, while it's running the application, will gather all the metrics from the application that it's running and send it to another application, to a remote application that we call the driver. The application that I will run to send a job to the server and the client and gather results of the job that ran. Okay? And then this driver, which is another application I will show you, will be able to display the results on the user screen or record it to a database. And that's how we do that with these charts. Whenever we run for a scenario and some time, we store the results in a database. And we have enough metadata to split all these results by hardware type, by host, by system, by type of value we are measuring, and then do charts from that. So that's what we are using. But it's not just for charting, it can also be used to do ad hoc measurements. So let me show you how it looks like when it's deployed. So we have this environment set up on physical machines in our lab, which are, so we have it running on a Windows machine, on a Linux machine. The load is always a Linux machine because we don't care about what is running, we just need HTTP clients. And we have the same environment in Azure on both Windows and Linux. And so this is important for us because the physical machine will give us more constant, well, how do I say, it's more deterministic results because we own the machines, we know when we can run the patches or do updates and what's installed on that. And so it's more stable environment to repro numbers, to continuously run numbers. And then the Azure machines are nice to be able to be close to what customers use and to see other kind of issues, and not the same also size of the machines. Like the physical machines, they have, how many cores do they have? I think 12 cores, and Azure ones, four of them. And we have another environment which is even bigger, which is exactly the same as the Tech Empower company is using. So this way we can exactly repro what Tech Empower is displaying as results. And that's something else we can do, and that's useful for us when we don't understand why the numbers of Tech Empower are different as us. We just run on the machines which are exactly the same as Tech Empower. So we have the server with the clients, and I have two consoles open here. So this is the machine that runs the benchmark server, and it's a physical machine. And if I open Docker, I see there is a container running. It's called benchmarks. Actually, it's called benchmarks server. Okay, this is the one. And if I look at what's happening, so the application is running and it's currently testing stuff. So this machine is always running, this service is always running, and we have some jobs that are continuously running to test all the scenarios all the time, and then gather and measure data and store them in the database. So this one, at some point we might see what time it is. Oh, maybe there is no job running and I will start one. So this is the server itself, and you can see, let me show you, you see there is some packages which are downloaded, restored. There is an app running, can we see it? This is the app running itself, and this is the app, in this case, that we are running to measure the scenario called plain text. So this is a Docker instance running on one server, and we have here this one. So if I do Docker logs benchmarks client, This one is sending a load, a client load, HTTP load to the application. And you can see it's using WRK, and we can see here a sample results from the machine itself. But these results, you see, and someone started, some process started a new load on a machine. It can be the Windows, it can be the Linux server, I don't know. But something is running. So now, let me show you how I can run it from my system. Here, I have the command line already prepared. So this is the benchmarks repository. And if I go here in SRC, you will find the server application, the client application, ASPNET Core applications, and the driver, which is a console app. Okay. This application is a web app that we measure performance on. So it is a generic web app with lots of scenarios, like lots of controllers, web APIs, stuff that calls entity framework, that uses middlewares, that uses MVC, everything. This is like a big bucket of different scenarios to test performance on. And this is this app that I usually ask the driver to run remotely and then measure a specific endpoint to test a specific benchmark. So here, from the command line, I'm in the benchmark driver folder. I will do .NET run, and then some parameters to set up the environment. I will give the URL of the service running the benchmark server, the endpoint for the benchmark client, then a file that contains the description of the job I want to run. Well, I'm kind of, where is it? Yeah, so this is continuing here. So benchmarks.plaintext.json. So it's a JSON document explaining, well, listing a list of benchmarks I can run if I don't want to type them on the command line, and then the name of the benchmark I want to run. And let me show you how it looks like in the JSON file. So if I go to benchmarks and I open this JSON file here, the one I'm pointing to, it's a JSON document. And let me see, you can read actually. So these are the default parameters, and I say the default parameters is to use the work client, and it will use pipelining, and will send some plain text headers. And this is where the app is actually hosted. And this is the branch, and this is the project to run. So this is super useful because I can point to any GitHub application to run on my environment. And you will see why it's super useful later. And the plain text scenario just says, based on the defaults, hit the /plain text endpoint. And there are many more scenarios in this file, like the plain text non-pipeline, which will reset the pipeline depth, which was set in the default node. And there is MVC plain text, which will also do a plain text, but on the MVC/plain text endpoint. And on the benchmarks app, this is just doing the same thing as plain text, but using the MVC action controller, and so on. You see, and you can have lots of different kinds of names of scenarios. So here, when I do dash and plain text, I'm just saying to the client, hit the /plain text endpoint, okay, with these presets. So I will run that. I will run that. Okay, I start. So first thing to do, it will contact the benchmark server at this URL, which I sent, to create a server job. And this guy here, oh, sorry, I went on the Linux machine, which is, did I open it? Let me connect to the Windows machine, where I sent the job actually. And we should have something here. Oh, this is running Signaler. Okay, let me, sorry. Some job is currently running there. So I will do the same thing, but targeting the Linux box. And we'll be able to see it there. So something happened. And here it says, okay, cloning this repository, starting the plain text. It's installing whatever the .NET runtime is necessary on this machine, in this Docker image. And then it's looking for the correct ASP.NET version. It's starting the app. And now the application has started. You see application started, press Ctrl-C to shut down. So if I go on the client machine then a job starts to send the load. And if I go on my own console, you see client job ready, so it's ready to start the thing. So this driver, the benchmarks driver, is what allows me to communicate with the benchmark server and the benchmark client to start application and to start a load. And after a few seconds, it's running a 15 seconds warm up and then a 15 seconds measurement. I should be able to see the result of the run. Let me go on the client. So the 16 pipelines. You can see the number of connections. So it's starting it. So I will see the results on this server before seeing them on my client, on my console.
Okay.
Okay, done. Oh, I see some results. So is it the result I was looking for? No, this was just the warming up. So now it's measuring. Starting again. It's important in this case to do the warm up because we want to measure the app not when it's called. We don't care about the startup time and everything. We want to know the best throughput that the application can have and to measure everything at max CPU load we can have on the server so we can detect the bottlenecks. And here is signalar, which means this thing has done. So the result from my application, from my side, I don't need to connect to the servers. I can just use my local application. I can see that this job ran for 1.6 million requests per second. I can see the CPU, the working set, average latency, the startup time, the time of the first request once it was started up, the latency when there is no load. So like the application is warmed up, I send one request, what's the latency of one request by itself? How many requests, how long did it take, socket errors, bad responses, the SDK that it's used on the server, the runtime it used, which ASP.NET Core version, and then, so I have everything here. And based on these results, we can already see what we can change as a parameter, which is super useful. So on the driver, what I can do is pass lots of arguments. And this is one of the best features of the driver. Oh, where is that? Benchmarks, driver, where am I? I'm lost. SRC, driver. So what is interesting here is that on the driver, we have lots of arguments. So we saw one argument, which was the -n, the name of the scenario I want to run. We also used the -j for the job definitions, the JSON file that contains job definitions. But what we have here is that we can define that we want to set a custom duration. So not 15 seconds, but let's say 5 seconds, because we don't need to run that. Or we could say we don't want to run a warm-up, or we want a warm-up with specific number of seconds. You can configure the client threads and number of connections also for the load. It's very important because we might want to push the limits of the system to see how it behaves when we have too many connections. Or maybe the system can handle more connections than the default, and we need to bump them. This is what TE is doing. Tech Emperor is doing that. When they measure with like 256 connections up to 1,000 connections.
Wow.
So what do we have here? So the two major ones, in my opinion, are these ones: ASP.NET Core version and runtime version. So by default, when we run a job, the driver will look for the latest available ASP.NET version from myget, and also for the latest compatible runtime version. This is how we detect the regressions early, because we are always using the latest version, which is on myget, the latest working build. But with that, what we can do is set a very custom version, like 2.1.0, for instance, for ASP.NET, or if we find a commit, we are not sure if it was a regression, we can just go on the commit number and find the ASP.NET Core version and then just run it for that. So we can go back in time to benchmark an application to see how it behaved like a month ago compared to today. This is what we use, for instance, in the KPIs. This part of the KPIs, baselines, this is how we do to measure how it was running in 2.1.0 compared to now. So we can detect regressions from 2.1.0 to see how we behave, okay? Or improvements. So, and these numbers are run all the time because the environment might change. So every day we still run it on 2.10 based on the current environment, physical environment or Azure. So we can do that, and that's super useful to be able to do that, to find issues. We can pass custom arguments to the application. We can use a custom port, but this we don't care. And this is also one of the best things. So I will ask, can we ask someone from the audience to do something for us?
Yeah.
The first one to be able, like we ask Ben, maybe we'll be able to do that quickly. Ben, I'm sure you have a Kestrel branch somewhere. Can you make it slow and make a branch on your repository that makes Kestrel slow, and we'll test it, just to show you what we can do with that. This is super useful. Did he say it okay? He say okay? I can't check the comments.
I don't see any comments on that yet. So you want somebody to?
Yeah, someone can create a fork of Kestrel or MVC or whatever, and slow it down, just for fun.
Okay. It's a challenge. I saw Ben Adams was on the chat. So.
Okay, just a thread slip in the HTTP parser. That would be nice.
Okay, he says, give me a few minutes.
What? Oh my God, so
I know, 10 minutes, that should be like 2 seconds.
Yeah, I don't even want it to compile. You just go to edit fork and you change the line of code and you just commit that. You don't even need to clone it. You can do it from GitHub. So this will let me point to any repository on GitHub, any branch, any commit number, and run the application in the state it was on this commit. And I will show you with the changes Ben will provide us. Project file, this is when you want to run a specific application from a repository that has multiple of them. This one I will show you later. Runtime store. So we have things or options also to decide how we want to run. This one is old. It's no more accurate. But what we can do is, let me show you, tiered compilation, self-contained. So we can, with the parameter, ask for the application to be deployed using the tiered compilation flag or as a self-contained. So this one that used not to be in the CSproj file. So we had to add this flag. Now you can define tiered compilation in your project files. That's easier. But this you still can't do. So this is super useful. So we can measure the performance differences between a standard deployment and self-contained, which means it will just embed all the DLLs you reference, even the runtime, even ASP.NET, in your published folder. And then we can measure the differences in terms of startup and throughput. And that makes a difference. So it's very important to know the impact on every app for this flag. And same thing for tiered compilation. So a few weeks ago, Noah Falk wrote a blog post, I think, and you mentioned that during your meeting, showing the benefits of tiered compilation. And how did he get all these numbers? He just used this benchmark driver and run all the scenarios he had in mind, and without the tiered compilation flag. And then he got the results from this console app. And he made a nice graph based on that. And he actually even automated all these things, so he can run that as many times as he wants on all the scenarios. That was very useful for that. You can also run the application with a specific environment variable, which is what these things actually do. You can download specific files from a server. So when we run an app, and the app generates some files somehow, like a DLL or like a static file, you can, after the fact, say the this file from the server, from what you run. Or you can say, fetch everything that you run. Like if we use a specific version of the ASP.NET runtime, if we use, I don't know, whatever code that is on GitHub to run on server, we can download everything that was run directly locally. So if I just do -- fetch, it will create a zip file locally of everything that was used to run on the server. It can be super useful to debug something locally.
Mm-hmm. Okay, question. So you're showing all of it, like this is really interesting to see how you are testing things and making sure that the application's quick. And is this something, this benchmark driver, is this something somebody could point at their own application to see if there are regressions or whatever, to do some performance testing on their own app? Or is this really more framework level?
No, this is for a real application. You can test a
Okay.
real application. That's the goal. We have micro applications, micro benchmarks, meaning, well, we test very specific endpoints in the benchmarks application to measure specific things, but you can test your own endpoints with that. That's really the goal. And I would like to do something with that. If you agree, John, that's all on you. My ultimate goal would be to provide a service like this, or for the .NET Foundation, to provide the server and the client on Azure, and that we could run our members, like library authors, their benchmarks to help them measure the perf on that. And it could be like I'm thinking about Image Sharp. You know Image Sharp. They are also providing a middleware, okay, and they are benchmarking it all the time. But I think they have an issue on their middleware that will be slow under load. And so I would love them to be able to provide to have an application, a simple application with 2 endpoints that they could follow the performance of their middleware and detect regressions. And even better, if they can test changes and see the real impact under load, that would be awesome. And this tool will help us, will help them to do that. And for the library authors or I don't know, application authors, that would be super useful for the community. So maybe one day .NET Foundation could host this service and they will be able to use it.
Yeah,
would be
that'd be
opt-in.
great.
Yeah. So that's my idea also.
Okay, so in the chat, Ben says patch-1, but I guess he can't paste in the full. Then he says poll 2864. So
okay.
I'm not sure if that's going to be
okay.
which.
So is it on this fork?
I don't know. Ben, is it on this fork or is it? I'm looking to see if I can find it too.
Oh, I found it.
Oh, good.
This one.
Remember, share your screen again.
Oh, sorry. Thank you. So he must have.
He said it's on his fork, and he also made a PR to Kestrel.
That's weird. How do I click to his? He made a PR on Kestrel. Okay, that's even better. Oh, thank you. That's better because I can click the link here. So you see, I see this is this thing.
Yep.
Okay. So the idea is that, oh, this is on this fork. So I will go there and say, Ben A. Adams. This is it. This is what I need, and this is the branch. So if I go there, I can say -r. So run the same plain text thing. Well, this is not the one I want to use. I will show you. So I will say -r, and I will paste the GitHub repo, okay, and I will say at this branch /commit, it can be whatever, at that, okay? But what I will use is actually the same repo. I will use the one here. Let me show you. On this repo, there is a platform benchmarks folder with the same thing, you see? Benchmarks, JSON, benchmark, plain text. So I can just go raw and say this is a JSON document containing plain text platform test. I will run that. So here I just say -j this file. So this is a JSON file I want to load. This is the scenario I want to run, which is plain text platform. And I can run it. And I will say -- no warmup. I don't care. Faster. And it should work. So the nice thing is that, well, if it doesn't work, you'll trust me. What did I say? Must have made a mistake. Plain text platform. Oh yes, no, there is no space. Well, it should have worked. But the idea is that we can point to any repository, and the server will just take it, run it, and benchmark it. So that's super useful for us when people provide PRs with improvements. They say, oh, I improved the performance by that amount, or can you check it's a nice improvement on your system? And by just doing this command line, we know if it's an improvement or not. And with Ben, we did that so many times when he helped us on Tech Emperor. He made all the changes that made he optimized so many things in the Tech Emperor Orchestral. That was super useful for us because he could just fork anything, create a commit, and we had like Skype discussions or Twitter exchanges where he would do a change, and the minute after he would get the numbers, and then another change, and the minute after he get the number. So he had live feedback about his changes on our environment with a stable set of baselines. So we knew if it was better or not. And so that's super useful. Something also we do is collect trace. So with just one command line, one argument, we run perf view or perf collect on Linux, and we get the ETL file to run perf view and see how it's behaving. So just one command line. That's also super useful for anyone who wants to run that. So that's the idea. To provide an environment where people can benchmark their applications way easier than what they would do otherwise, and a stable environment. And also what we do for Tech Emperor is that we can run Docker images. So what we have in the Tech Emperor repository, well, what they have, not what we have, what they have, but that's fine for us. If I take the C#1, the ASP.NET Core 1, since February, what they're doing is that they are using Docker files. Okay, so this Docker file will set up the environment to run the MVC scenarios. And what we do is that with this benchmark tool, we can just point to the Docker image from the JSON document, and then instead of deploying the app and building it, it will just run the Docker image here and start a load from that.
Oh, wow.
So that's what I did actually yesterday with Bradley Granger, who is the author of the MySQL driver for AD.NET. So let's look at that. Yesterday, there was a PR from, you see, Bradley. He made a PR on Tech Emperor, directly on Tech Emperor, to update the MySQL connector version and to optimize the benchmarks. Okay, you can see the file changes. And at some point, he was like, okay, is it faster or slower? And then I'm like, I'm concerned about this change. And okay, can you test this branch at this commit and this branch at this commit? So what he did, he knows how we work because we worked with him also on this thing. So to improve MySQL and MySQL connector, sorry. And so what he did is that on his fork, he just created two changes that he doesn't know the result of the perf, but he asked us to just run the numbers. And boom, just one command line. I just pointed to his repository at this commit, exact commit, and then we got the numbers from before, after. And I could tell him, yes, go commit that. And then the Tech Emperor guys, they just merged it. It took like 1 hour. It was super awesome. So that's also how it helps us to help the community improve their results. Not mentioning that with Shai Rojansky, who is the owner of the NPG SQL driver, we also did the same thing for weeks to work on the perf scenarios that we were measuring on Tech Emperor. So that's how we work. You see, you create a PR in Kestrel, in MVC, in our benchmark, and we can run it on the fly to get feedback to you or to ensure that we are not regressing anything. So yeah, that's the idea.
Wow. Yeah, so that saves you from having to, every single time someone asks, having to clone and build and run it locally and set it up and test. This is something where you can just point it at, and your testing infrastructure handles that.
Yeah, that's why I would love the Net Foundation to provide that for our customers.
Yeah, that makes sense. We'd have to figure out some of the things. I mean, obviously with things where you can load tests from a server, you don't want to... That's super easy
to say, but to put in place legally and everything, that will be the other issue. At least, opt-in, so we can myself, I will say, sorry, set up the environment for them, and they point me to the application. I will configure it so they don't have to touch anything. They will know the numbers. That would be nice.
So you talked about like the testing side of it. Can you show us some more like what you've done? Do you also work specifically on like, okay, how do you see that something specifically is slow, how do you work on making it faster?
Yeah, so I will use this question to go on the next topic, which is people report issues. How do we do then? So there, let me open this link here. This issue. This one is interesting. So this issue was created last year. Here, ASPNET core not collecting garbage. That's a big issue, right? We should look at it very seriously. So it was opened last year, and the idea is that user reported that the memory is just growing with a simple web API call. So that's something we don't expect, and that's a very simple scenario. So if we had an issue, we will know. So the question here is to understand what triggers the issue, what is the actual issue, is there an issue? But the main problem we had with this issue is that people were coming with, oh, I have the same thing. You see, yes, I also seen this. Or facing same issue here, and blah, blah. So I'm like, 10 people report the same behavior, but not the same thing. These are all different cases, actually. But they all worried about the memory usage. Okay, so and that's understandable. I'm like, I don't want my app to use all my memory. And look at that. So many people saying there are issues, and we are like asking every one of them, can we report? Can you share something with us? What's your environment? And you see 28 more hidden items here. So I'm like, oh, wow. And up to the point that we could not follow up with all the questions and all the comments. So Maoni suggested to stop this thread and to just split it into different issues because they are all talking about different things. And it's a loss. And also the thing I found is that why is everyone asking the same question, but with different scenarios? And maybe it's not the same issue, and maybe there are no issues, but how to prevent everyone from saying there is an issue when there is not. So I worked on every scenario here. So let me show you first. So I split this one into different issues. Some of them have been closed because we found the issues which were on the user code usually, and we could close the separate issues. Some are still open because I'm waiting for feedback, but most of them are false negative. Maybe one might be serious, so I will have to check this one. And I said I will write an article about how we can detect those changes, or to detect that there is no issue. Okay, not those changes, to detect those issues and that there is actually no issue. So I worked on that, and I made an app. It's called Memory Leak, which is a very bad name because there is no memory leak. It's just to show some things we can do. So this app, I will run it. The goal is to understand how the garbage collector works. So what this app does, the simple web API app with a razor view that will display live the working set of the application, which is the blue line. Okay, what is the memory used by the process, including managed objects and native memory. The allocated bytes in managed memory, like how much objects like managed data is in the memory. And we can see then the Gen 2, Gen 1, Gen 0 collections, how much CPU is used and how much RPS we have. Okay, so that's the idea. And the goal is really to understand how the garbage collection works and memory and pitfalls in ASP.NET Core you could do and how it behaves. So on this app, I will put some load just to see how it behaves, a simple app, a standard app. And you will see exactly the behavior from the issue that was created in GitHub. So if I go to, I'm using GoBench, which is a tool to send some load, but it works on Windows, so I'm fine with that. And I will do GoBench, one connection for 1 second. It doesn't matter because it will run infinitely. And I will go to the URL, this/API/big string. So what is big string? It's a big string. Where is that? API controller. So I have this big string here. It's just returning a new string, 10 kilobytes, but it's actually 20 kilobytes of in memory because it's using 2 bytes per char. So get string, and I'm doing that as fast as we can. So whenever we have the result, we are sending a new request. I'm starting it, and on the web app, we can see that the memory is growing, and we can see the allocations. And every time the GC collects something, we can see that the managed allocations are going down. And the green arrow is a Gen 0 collection, the orange arrow is a Gen 1, and the black arrow is a Gen 2. And here we can see we just have Gen 0, which means short-lived objects. The Gen 0 is a section in memory that contains short-lived objects. And as the objects are not collected because they are still used, they will be moved to the Gen 1 and be collected less often. And if they are still there during the next collection, they will go in the Gen 2 and be collected even less often. So usually, whenever you do a request, all your objects, they go in Gen 0, because the objects which are lived just for the time of the request, they are short-lived objects. So this string is just short-lived object. It goes in Gen 0. And then when there is some threshold which has been hit, the GC will just say, okay, we need to do a collection. Let's do a G0 collection, a Gen 0 collection, and it will collect everything. And we can see we have a collection every 2 seconds. A square in the grid is 1 second. Okay? And the memory is at around 400 megabytes. And that's super stable. And this is exactly, well, it's stable. The user was saying it was going up, but it's actually super stable. And I'm doing some load of 4,000 requests per second right now. Okay? We can go faster, but that's how it works. So there is no GC leak, or the GC is actually running correctly. Otherwise, we will know. It's just to show that, yes, a standard ASP.NET application under the default settings might take, because I have 32 gigabytes of memory, will take 400 megabytes of memory. That's the normal behavior of the GC. It will adapt on the available memory. So just to show that. And then by extension, I wanted to show all the issues that people explained in this thread, in the GitHub thread. If I go and just show the worst thing you can do, which is instead of returning the strings directly, store them in a static dictionary, or statically. So here I have a concurrent bag, static strings, and it's static. So it will live for the full lifetime of the application, and I'm just adding strings to that. And everyone can guess what will happen. The memory will just grow up. Static string, under load. If I hit the correct endpoint, yes, and you see the memory. So we can still see the garbage collector working, but now with Gen 2, it's trying to remove as much memory as it can, or now Gen 0. But so it can collect some things. It will collect some things because some strings are allocated and can be released. But the memory will grow indefinitely until we hit out of memory exception. And I won't go to this point, okay? I don't want it. And then the memory is stable because I'm not creating new strings, but they're still in memory because they can't be released because they are referenced statically by a collection. Okay, make sense? So I will close the application because now it's using too much memory, and show you another scenario. So I showed you some transient objects with the strings, and so this is the startup of application. What I want to show you is, so let me restart. No, I will go directly here. I want to show you the workstation garbage collector. So the garbage collector by default runs in a mode called the server garbage collector, which is optimized for server loads like ASP.NET Core. And this is why we use it as a default. If you go in your application and look in the hidden files, in the released folder, well, in the deployed folder, you will find a file called runtime.json, runtimeconfig.json. And here there's a property, system GC server true, that says that we want to use the server GC. If we want to use the workstation GC, we can change it at the CS proj level by saying server garbage collection false. I will save it and rebuild it because it's a build setting in this case. But you can change it before starting your application by changing this file directly. So I will run it again. but now it's using the GC mode. So far so good, same thing as before, but if I do a load with my transient objects, my big strings, here the difference with before is that it doesn't go to 400 megabytes, it just keeps at 75 megabytes. But we don't have a collection every 2 seconds, but some Gen0 like 5 times per second. And the allocated memory will be kept under 15 megabytes because the GC won't wait for it to go up to 300 before starting. It will run much more often, which means we won't reach this amount of allocations. And so the big improvement here is that we are using much less memory, but we are doing much more GC collections. And GC collections will take some CPU. So the workstation mode is not optimized where CPU is a bottleneck. Okay? But maybe if your application is actually memory hungry or is limited on your system by memory, maybe you want to try the workstation garbage collector. That's not something that is recommended, but I could see some scenarios like on shared hosting where it will make totally sense. So that's interesting, I think, to know that there is something like this, and if memory is a big issue for you and the GC behavior is a big issue, maybe you should try that. I will personally try that of some of my applications just to see, because in this case I don't care about CPU usage. It can collect as much as it wants. I just care about the memory usage. So something that is interesting also to see visually how it behaves, because it's just some terms that people have heard but maybe never seen how it works. So that's the workstation GC. Then another scenario where we see issues is actual memory leaks. Let me show you an actual memory leak. So I will go back to the server GC, and I will go and test this one, the file provider endpoint. So let's running. Is it running? It's not running. Start. Okay, go. Same setup. Now I will go to this endpoint, file provider, and what we'll see is that the memory will just keep growing. So what's happening in this code is that I'm instantiating a new file, a physical file provider, which is very typical in ASP.NET for static files. And I'm watching them. I'm watching the files from this folder. It's a temp folder with nothing inside. What I'm doing is that I'm newing up this thing and calling that. I'm not disposing it, even though it's disposable.
Yeah.
But I would not say now, because sometimes you don't want to dispose. We'll see later. But the issue is that it's a managed object. I don't call dispose, but it will be collected by the garbage collector. Okay, we see garbage collections. It will be collected. But this, because I'm not calling dispose, and because there is no finalizer, the dispose method will never be called, though it should be mandatory for this class to call the dispose method. So yes, we should do a using, but the issue is actually in this class, we should have a fallback mechanism to say if dispose was not called, we should call it when the object is collected by the garbage collector. So there is an issue with this class, and it's already filed actually.
Oh.
So it's very interesting because I think this is, where is that? I don't have the link to that. But there is an issue which was filed, and there is currently a PR that has been opened by a dev on MVC to fix that indirectly. So that's a typical issue. So if you don't dispose what should be disposable, what is disposable, you might have issues. Not all the time, but in this case, this is a big issue because the memory will keep increasing, and you will get, this is a memory leak. Okay, so be careful. And this is an actual issue on the MVC repository because, or maybe on the, I don't remember which repository, because the hosting environment is actually referencing that and doing lots of watch. And if you, in the case like you are doing unit testing, and because we are not disposing it from the hosting environment, then we'll get a memory leak. When you do unit testing, that creates lots of hosting environments, which itself creates physical file provider. So that's why I wanted to show that, because there is an actual issue that you could hit if you do unit testing for that. Otherwise, in production, you will never see this exact issue. Yet we'll fix it. So keeping on the disposable things, this is an HTTP client. This one is obvious, but I wanted to show it. So if I go and just hit this endpoint, which is HTTP client 1, it's creating a new HTTP client. HTTP client is disposable, so we are doing a using block, so we are displaying it. Just calling a standard URL. I can use. You will trust me because I don't want to encode that, but I could just paste a URL there and it will do another HTTP client on that. The issue with that code is that HTTP client should not be disposed, or actually should be reused. Yes, it should be disposed, but you should reuse the instance of HTTP client as much as you can. So this is a bad pattern. If you do that, you will get some port exhaustion. Like the connection will be created, but HTTP client will be disposed, but the connection itself won't be released by the OS as fast as you create new HTTP client. And in the end, at some point, after a few seconds, you will get port exhaustions on the client, and you won't be able to create new HTTP clients. So the idea is that this explicit class, HTTP client, needs to be reused. So a simple technique is just to put it as static and to reuse it on every request, the same instance. It's a thread-safe instance, so we should reuse it. And that's how it's supposed to work. And then, obviously, when the application shuts down, we should dispose it. But in its case, that's fine. We just have one. When the application will shut down, everything will be cleared correctly. And even better, use the HTTP client factory. And there is also a blog post that was written when 2.10 was shipped. So that's a new thing, but just a reminder that reuse your HTTP client instances or put them static if you don't know how to do it correctly. That's the best thing to do. Next thing I want to show is the large object, not this one. I want to show the large object heap. This is also a very typical issue we see, and that's a magical example. I love it. So I will stop this application. What it's doing here, it's stuck at 700, or let me restart it. I want it to be clean. Restarting it, and now I will call this one with a magic number, which is 84,975, exactly. And this is not by chance. Oh, maybe I'm too, here, it's better here. So I'm running it. That's a bad example. So maybe it depends on the days. So sad. Interesting. Oh, I know. Did I? Oh, yes, that's why. Okay, sorry. I don't know how to use Web API. Stupid. Slash size. I think that's it. Okay, that's how we do that. Look at that. That's better. Okay. So I'm calling with 84,975, which is actually doing what? It's just creating a new byte array of the size I'm passing here and returning the length, just to actually instantiate it, and I don't want to return everything, just want to instantiate it. So I'm creating a byte array of 84,975 bytes. And what I see here is that it's allocating, and I bet, no, is it good? Am I in workstation GC or? Yeah. So that's not what I want. I want to see the server GC. So I need to rebuild. Did I save my csproj file? Yes, now it's better. I just need to rebuild. I will start the load again, and I will see the same behavior, but you see I will go to my 400 megabyte memory, and you see I can see gen 0 every second. Okay? That's the idea. So I can create these large objects, that's fine. But now, if I do plus 1 byte, just one more byte, it's totally different. I don't get Gen 0 collections, which are cheap. I get black ones, the Gen 2 collections, which are more expensive because a Gen 2 collection will also do a Gen 1 collection and a Gen 0 collection. So by definition, it's slower than Gen 0 collection, okay? And I get them much more often. So it will take much more resources than just one less byte. So why is that? It's because when we allocate objects in memory, they will be put in contiguous segments of memory, and they will take space. And once objects are collected, we will release this space. And this can lead to fragmentation of the heap segments in memory. To prevent fragmentation, because fragmentation is bad, it's like on the hard disks, you don't want fragmentation because you have to find a slot which has enough space. So what the GC does, it will do what is called compaction. So it will move for each generation, it will move the bytes of each object which is in the heaps, it will move them to compact them. It will defragment the memory. But the issue is that defragmenting is costly when you move memory. Moving memory is costly. And at some point, it's less efficient to move large blocks of memory than just having fragmentation. So the idea is that they decided that 85,000, not 85 kilobytes, but 85,000 bytes was the limit after which they should not even try to move the objects. And they leave them in a specific zone in the garbage collection, in the memory, that is called the large object heap. So any object that takes more than 85,000 bytes in memory will be only collected by a Gen 2 collection and will be placed in a specific zone where they don't move, they are not compacted. And the recommendation in this case is to be careful when you create large objects, when you serialize them, when you do big allocations of strings of JSON documents, that it might go in the large object heap and impact the performance of your system. And you see, 1 byte makes a difference. So it's not exactly here 85,000 because the bytes themselves take some space in memory, but maybe also the metadata for the byte array itself, for the structure of data, takes maybe 25 bytes. That's why I had to go from 75 to 76. But that's super, the fact that just adding 1 byte has so much difference in the profile, that's I think super important to understand. And you can see metrics when you analyze the heaps of how much objects you have in the large object heap. And that's very important to understand that. And that was, lots of issues were reported on this issue, and that were related to a large object heap. You see here, so people ask questions about why do you have that, and then we are like, do you have big objects, and so on. And you see here we can have statistics from the analysis tools about how much is the object heap, large object heap. So that's important to understand. I think we are on time, and the last example would have been object pooling. I will just mention that because that's a good technique to do. If your objects are costly or take lots of memory, you need to pool them. And something not everyone might know on ASP.NET Core as a ASP.NET Core developer is that, let's look at this example. If I do get array and I give a size, it's just creating a new byte array of this size, filling the array with bytes and returning it. So there is no pooling here. But if I wanted to pool the array, but still, so I want to return an array, but still pool it, like be able to reuse it when the request is done, because when I return something, I can't say when it's free to be reused by a pool. So a technique is to, here I'm creating a pooled array, which is wrapping an array, okay, byte array. And what I do is that I'm using the array pool, which is passed here. This is a static object. I'm using an array pool, and when it's created, I'm pooling the array by calling rent, and when this object is disposed, I'm returning the array. So it's a wrapper around an array. And what it's doing here, I'm using a pooled array, this class, which is disposable. And here, this is the magic thing, which is on the response object, you have a register for dispose and an object. And the idea is that when the request is done, when the response has been sent, ASP.NET Core will call dispose on this object when the request is done. So we can be informed when the request is done and release an object, or call dispose on this object when it's done. So I can safely return the array and then call dispose on this one when the request is done to warn that this array can be returned to the pool. Otherwise, if we do that here, there is no way to know when it's available again. And it's even worse to pull something that we can't return because we will like keep some references to it forever. So that's a nice trick. I think we should know as an ASP.NET developer how to detect when the HTTP request is done and call dispose on that. Yep, that's it.
Great.
Have questions?
I don't see any towards the end here. I think that's probably a good place to wrap up. I guess the only thing I would say is for people that want to keep up with the work that you're doing, so you did point out the one place where the AKAMS link where people can go and look at benchmarks. Is there anything else that you'd recommend for people just keeping up with performance as well as performance and troubleshooting on their own applications?
Troubleshooting, well,
I mean, not troubleshooting, but for instance, okay, my application's running slow. Is it my fault or is it ASP.NET? Is there a bug in ASP.NET, that kind of thing?
Yeah, so we are trying to gather that. So what I explained with the typical patterns of memory management, we'll release an article with that. So for sure, whenever we see a typical issue like this, we'll ask people to read that and to see if there can be one of these issues in their application first. We want also to do the same thing with typical usage of APIs we have in ASP.NET Core. I'm thinking, for instance, about what's the name? Concurrent dictionary. The concurrent dictionary, when you pass a lambda to create an item, it might call this lambda multiple times. It's not locked, and people don't know that and expect that to be thread safe, to be locked completely. So there are some subtleties in the APIs that people might not know. I want to have a reference about that. So whenever usually there is an issue, we can point them to a list of best practices, or do you know about that? Do you know about that? Maybe that's it. So they can by themselves check some things that are obvious in ASP.NET Core and probably find the solution to their issues.
Great. Okay. Well, that's probably a good place to wrap up. Anything you'd like to say? So we don't have the dramatic zoom out available to us. All we can do is basically back away from the screen. But anything you want to say before the pretend dramatic zoom out?
Thank you.
All right. Well, thank you very much. Okay, so I'm going to slowly roll away from my screen and dramatic zoom out, and thank you very much.